Okay, done? Can I explain? Okay. One more statement is there for Kirchoff's current law, junction law. That statement is statement number 2. So according to sign conventions, we define statement number 2. How much amount of running అవుతుందా? So according to sign conventions, those currents are entering into the junction that currents can be taken as positive. Then must and should those currents are living from the junction. That currents can be taken as negative. That currents can be taken as negative, vice versa. So according to above point, the algebraic sum of all the currents at a junction, will be equal to 0. That is, sigma I should be equal to 0. So according to sign conventions also, we define Kirchoff's current law, junction law. Those currents are entering into the junction, that currents can be taken as positive. Then must and should, those currents are living from the junction, that currents can be taken as negative, vice versa. So according to this point, the algebraic sum of all the currents at a junction will be equal to 0. Now I am going to explain statement 2 related to Kirchoff's first law, junction law, with the help of simple diagram. Here I am taking 1, 2, 3, 4, 5, 6, 7, 8. I am taking 8 conductors. These 8 conductors are meet at this point. This point can be called as a junction. Here through 8 conductors, currents are flowing. So through first conductor, I1 current is flowing towards the junction. Through second conductor, I2 current is flowing away from the junction. Through third conductor, I3 current is flowing away from the junction. through fourth conductor I4 current is flowing away from the junction. Through sixth conductor 1, 2, 3, 4, 5. Through fifth conductor I5 current is flowing towards the junction. Through sixth conductor I6 current is flowing towards the junction. Through seventh conductor I7 current is flowing towards the junction. Through eighth conductor I8 current is flowing away from the junction. According to statement 2, sigma I should be equal to 0. So what is the meaning of sigma I should be equal to 0? The algebraic sum of all the currents at a junction should be equal to 0, because out of all the currents, some of the currents are flowing towards the junction, some of the currents are flowing away from the junction. That's why I am writing like this. The algebraic sum of all the currents at a junction should be equal to 0. Now I am using sign conventions. Out of all the currents, which currents are flowing towards the junction, that currents I am taking as positive. Which currents are flowing away from the junction, that currents I am taking as negative. Okay. See, I1 current is flowing towards the junction, plus I1. I2 current is flowing away from the junction, minus I2. I3 current is flowing away from the junction, minus I3. I4 current is flowing away from the junction, minus I4. I5 current is flowing towards the junction, plus I5. I6 current is flowing towards the junction, so plus I6. I7 current is flowing towards the junction, plus I7. I8 current is flowing away from the junction, minus I8, should be equal to 0. So I1 plus I5 plus I6 plus I7 should be equal to, taking minus I2, minus I3, minus I4, minus I8 to the right hand side, it becomes plus I2, plus I3, plus I4 and plus I8. I2 plus I3 plus I4 plus I8. This is exactly we can be called as Kirchoff's current law or junction law. Observe this equation. So these currents are flowing towards the junction. We have to add these currents, should be equal to sum of those currents which are flowing away from the junction. Sum of the currents entering into the junction should be equal to sum of the currents leaving from the junction. So this is exactly we can be called as Kirchoff's current law, junction law, according to sign conventions. So based on this concept, I am going to find the values of currents I1, I2, I3, I4 in the given circuit. Okay. This diagram, 15 amperes current is flowing through this resistor, and here this is called as a junction. So here at this junction current is divided. So here out of 15 amperes, 8 amperes current is flowing. What is the remaining current? What is the remaining current, children? 7. So what is I2? 7 amperes. So out of 15 amperes, at this junction 8 amperes current it should be divided like this, remaining 7 amperes current it should be flowing like this. Now again here this is also we can be called as a junction. Here at this junction I2 7 amperes and 3 amperes, these two currents are meet here. Okay, and finally, how much amount of current it should be flowing away from the junction? I3. So what is the value of I3?
4 amperes.
What is the value of I3?
4 amperes.
Not 4 amperes. 7 amperes plus 3 amperes. 10 amperes. Okay. Now, in this diagram, this is also we can be called as a junction. So here, with respect to this junction, I4 and I3, these two currents are flowing towards the junction, but we don't know the value of I4. So first come to here, come to this junction. At this junction, 8 amperes current it should be flowing like this. So here and here at this junction the current it should be divided. So in this path, what is the current? 5 amperes. So now out of 8 amperes, 5 amperes current it should be flowing like this. What is the remaining current? 3 amperes. 3 amperes current is flowing. So with respect to this junction, I4 and I3, these two currents are moving towards the junction. So finally these two currents are meet here. Now the current I1 flowing through this resistor will be 10 plus 3, 13 amperes. 13 amperes. This is how we are calculating the values of I1, I2, I3, I4 with the help of current law or junction law. Okay. So this is the concept for Kirchoff's first law or junction law. Okay, thank you.